In this video, we're going to have a look at Venn diagrams. In the previous video, we had a look at simple events, for example, drawing a card from a deck of cards. When more than one simple event is taken into account, it is called compound events. To ease your calculations for compound events, you can represent the information in different diagrams. In grade 9, we had a look at tree diagrams as well as two-way tables. And now we're going to have a look at Venn diagrams. For a Venn diagram, we start with a rectangle, and inside the rectangle is the whole sample space, meaning all the possible outcomes. In this rectangle, we then indicate the different events that we are looking at with circles. Let's suppose our sample space is all the grade 10 learners from a school, and we are looking at their subject choices, specifically life sciences and accounting. In this case, there will be learners that only take life science, and there will be learners that only take accounting. But there will also be learners that take both subjects, and that is why the two circles will intersect. And then there's also the chance of learners not taking either of the two subjects. Those learners will fall outside the circles, but still in our rectangle sample space. The information in a Venn diagram can be indicated in three different ways. Firstly, the actual outcomes can be shown. In our examples case, each learner's name will then appear in the Venn diagram. The more learners there are, the less ideal this method will be. The second option is to indicate the number of outcomes. In our example, we now have 150 learners, of which 60 take only life science, and 50 take only accounting. 15 of the learners take both these subjects, and then there are 25 who take neither of the subjects. The third option is to indicate the probabilities. So in our example now, we know that the probability of choosing someone who only takes life sciences is 0.4, those only taking accounting 0.35, and those taking both subjects will be 0.1. The probability of choosing someone taking neither of these subjects is 0.15. Now also remember that a probability is always out of 1. So if we add up these four probabilities, you will see that the sample space has a probability of 1. Example 1. The letters of the word dangerous are written on cards and placed in a hat. One card is drawn randomly. Let A be the event in which a vowel is drawn and B the event of drawing a consonant. Question A. Write down the outcomes of event A in set form. When writing down a set or a list, in this case for event A, you make use of curly brackets. You are asked to give the outcomes for event A, which is choosing a vowel. The vowels are A, E, I, O, and U, and in the word dangerous we have an A, E, O, and U. So when listing all the outcomes, we have A, E, O, and U. Question B. Give N of B. Here you need to know that N is the symbol for the number of outcomes, in this case in event B. Event B is drawing a consonant, and we have a D, N, G, R, and S, which means there are 5 outcomes in event B. Question C. Draw a Venn diagram to represent the number of outcomes of events A and B. In our Venn diagram, we will have 2 circles for the 2 events. These 2 circles will not intersect because there are no vowels that can also be consonants. We are asked to indicate the number of outcomes. The word dangerous has 9 letters in it, so our sample space has 9 possible outcomes. Event A is the outcomes for drawing a vowel, and we've already seen that there are 4 possible vowels in this word. And in question B, we said that there are 5 outcomes in event B. The 4 outcomes of A together with the 5 of B make up our 9 outcomes for the sample space, which means there are no possible outcomes outside of these two events. Question D. Give the probability of choosing a letter in A. These are all the vowels, and we've already said that 4 out of the total of 9 letters are vowels. Example 2. In a survey that was done at a school, it was found that out of 180 girls, 90 girls play netball, 65 play only hockey, and 15 girls play both netball and hockey. Question A. Draw a Venn diagram to represent event A, netball, and event B, hockey. In this case, our Venn diagram will have 2 circles because there are 2 events. But this time the 2 circles will intersect because there are 15 girls that play both netball and hockey. The whole sample space consists of 180 girls. When the events of a Venn diagram intersect, it is very important to start adding the information at that intersection. This means we'll start saying that there are 15 girls who play both hockey and netball. The next part of information is that 90 girls play netball. It is important to see that it doesn't say 90 play only netball. Therefore, the 90 girls represent the whole circle of event A. Of the 90, there are already 15 learners that play netball and hockey, and that means that there are only 75 left that only play netball. Next, we are given that 65 girls play only hockey. That means that they represent the part of the circle that is only for hockey and not intersecting netball. So the 65 can immediately be put into the circle. Our sample space consists of 180 girls, but at the moment, adding up the 3 values that we have is only 155 girls. Therefore, there are 25 more girls that do not play hockey or netball. Question B. Determine the probability that a girl chosen at random will not play hockey or netball. Here, our Venn diagram will come in handy because we already know that 25 out of the 180 learners do not play hockey or netball. Simplified, that is a ratio of 5 out of 36.